All right? If you haven't already done it, right? Name, date, period up at the top, assignment number. Okay, bless you. All right, so today, actually going back to yesterday, we went into deep detail about what inequalities actually mean, and in mathematics, but obviously in real life. Okay. Now, what we're going to do is we're going to take the concept of inequalities that we talked about yesterday, and you're going to see them written out as problems. All right. So that's basically what it means by solving inequalities. Okay. So no new vocab words. It's like solving. You're going to find it's very similar to solving equations. Okay, with a little twist here and there, but we'll talk about that when we get there. Okay. So let's go ahead. If you haven't already done so, go ahead and grab your book, and let's flip to 370. 370. All right, so really quickly, just eyes up here. I'm going to do one of the easier problems. All right, so problem number 2. And it's nice because you won't even have to copy this down because it's not part of your homework assignment. But I just want you to watch. So what we have for number 2 is we have on page 370, b plus 20 is greater than negative 13. Okay, now what this is this is a inequality, all right, sentence that we're going to need to solve for the variable. Guys, guess what? It's exactly, this part anyway, is exactly like solving a regular equation. Okay, it has a little bit of a different meaning like we talked about yesterday, but the steps are just the same. Okay, so you have your variable, you stick to that side, you do the inverse operation. In this case, 20 is being added to b, so I'm going to subtract 20. Whatever we do to one side, we need to do to the other. Subtract 20 there. So we end up with b is, and be careful because this is one of those parts where people get like just kind of in the flow of things, and they just automatically, because you've been doing it for so long in school, you just put an equal sign. Be careful. It has to be a greater than sign because we now know, right, that's a different meaning than an equals sign. And then, of course, both negatives, right? So I add them up, and we end up getting a negative 33. B is greater than negative 33. Okay, so that's kind of a basis of what we're doing today. All right, so what I want you guys to do is now pick up your pencil. Let's take a look, okay, at one of your homework problems. Let's take a look at problem 34. All right, so if you haven't already started, go ahead and write down your problem. All right, so we have a negative 3/4 d minus 6 is greater than or equal to 9. Okay, here we go. If I took a look at it, if this was had an equal sign, this would be considered a two-step equation. Okay, so what I'm going to go ahead and do is treat it like that. So the very first thing I'm going to do, the first step is I'm going to box in what I call our variable term. I mean, it's the term with the variable in it. Okay, we have a coefficient up front. And when I do that, I'm going to go ahead and do step 2, and that is I'm going to go ahead and do the additive inverse. So when I do the additive inverse, so the opposite of minus or negative 6, positive 6. And step 3, of course, is we do the same thing to the other side. I'm going to go ahead and add 6 to this side of the inequality. So, of course, where we did the inverse, they cancel. So we bring this down, negative 3/4 d is greater than or equal to 9 plus 6 is 15. Now we're gonna, I think when we did two-step equations, I just said like repeat steps 2 and 3, okay? And that's pretty accurate, but I'm not. We're going to break it down even further because of a situation in this problem. Okay, and that's actually this very next step. Well, actually, sorry, not this next step. I'm going to go ahead, keep knowing where your variable is. All right, and then this is the step I'm talking about. Step 5. Okay. On step 5, it's being multiplied with -3/4. So I'm going to do the multiplicative inverse here. Now, here's what I would like you to do. With inequalities, you could put a big reminder star asterisk next to it. You could highlight it. You could do whatever you want, but this is the main thing that you're really going to need to know in this lesson. All right, here we go. When you're dealing with multiplicative inverses, you're going to solve it the exact same way. So remember, I can divide both sides by -3/4, but remember, with a rational coefficient, remember we instead save ourselves time by multiplying by the reciprocal, right? We do the KFC all in one shot. So we multiply by -4/3. Of course, we do the same thing to the other side, -4/3. And I guess maybe we should have put this on step 7, the asterisk, now that I think about it. It is all part of multiplicative inverse, okay, what we're about to do. It's not about additive inverse, it's about multiplicative. Anytime you're multiplying or dividing. So here's what we're going to do. These cancel like it normally would. We get D. On this side, we need to solve. Cross reduce. A lot of these problems will allow you to cross reduce. It makes it a little easier on you. Divide both of them by 3, so I get a 1 here and a 5 here. And in this case, it's 5 times 4 on top, 1 times 1 on the bottom, so it ends up being 20/1, or just 20. Now don't forget though, right? It's a positive times a negative, which gives us a negative. Okay, here's what the asterisk is about. When you are using multiplicative inverse with an inequality, you multiply, okay, or you divide you're going to go ahead and change the inequality. You're going to flip it. Okay. So, you know what, I don't even know if I said this right now. My apologies. When you multiply or divide, I should say maybe we should put this here. By a negative number. Sorry. That's a big important piece of information. I think I just went through it and forgot to say it out loud. Anytime you multiply or divide by a negative number, you flip the sign. Not on additive inverse, only on the multiplicative. You multiply or divide, okay, by a negative number. Almost said it again. By a negative number, you flip the sign. That is the main difference in this lesson today. Okay, questions?
So if there is no negative side to multiply, do we keep the side how it is?
Yes. You're talking about a multiplying or divided by a like a positive number? Yeah. You would remain the same. Okay. Guys, other questions? So if you take a look at the directions, right, it says solve each equation, graph each solution on a number line. So, okay, thank you for pointing that out. If you guys take a look, though, just make sure you read, because it goes back and forth on tonight's homework. So if you take a look, right, number 11 through 24 just says solve the inequality. Okay, 25 through 38. So every time there's a new heading, new set of directions, make sure you read them, right? So yes, so after this, it does say, because this is number 34, solve each inequality, graph each solution on a number line. Okay. Now, before we do that and go on to the second part of this problem, any other questions on that? I don't want anyone to be confused because I said it a couple times without saying the word negative. So we're okay. Okay. And then, of course, yes. And like I said, there's so many different little steps, right? But I mean, it's all pretty repetitive. I did need to break that second part down where you knew that step right there. So step 8 is graph it if it asks for it, right? Might want to put a little star by that. If it asks for it, you do step 8. So this is all review from yesterday. So we have our graph. It's being compared with negative 20. Okay. Remember, there is part of an equal sign, so we put a dot. D is smaller than negative 20, right? We're always graphing the variable, so you point your graphed arrow to the smaller numbers. Okay, guys, questions on that? Okay, so I mean, almost every single part of this was review except this asterisk right here. Okay. Remember, multiplying or dividing, that's what multiplicative inverse is, of a negative number, a fraction or even a whole number, you flip the sign. Okay. If you're afraid you're going to forget when you get home, maybe take step 5 and point a little arrow at both signs to show yourself that you flipped them if you're afraid you're going to forget. All right, other questions? All right, here we go. Problem I want you guys to do is problem number 30. Problem number 30. All right, go. Okay, how many of you are still working on that? Okay, you better now check in with you about another 30 seconds. Okay, anyone need more time? All right, so 30 seconds. All right, so during those 30 seconds, guys, make sure you have every single part of it showing work on both sides. Make sure the inequality solution is written correctly, and then, of course, the graph matches each other as well. All right, 30 seconds, go.
I got 96. Oh, I got 96 in this one. I added 9 on both sides, got 24, and I multiplied by 4 because it's division. Then once I multiplied, I got 96. Oh wait, I think it's
All right, here we go. Number 30. Number 30 was 15 is less than or equal to negative k over 4 minus 9. All right, so just looking for a solution here. All right, so just your final solution. All right, not a graph yet. Seat 9.
I didn't finish it yet. I will.
Okay, seat 18.
I thought k is greater than or equal to negative 96.
Okay, agree, disagree. K is greater than or equal to negative 96. Okay. Nice chunk of you that have that. All right. Tell you what, before I pull notes, anyone else have another solution they feel is correct?
K is less than or equal to negative 96.
Okay. Agree, disagree there. All right. Some agreements. All right. So between those two, it looks like we're kind of split. Are there any others that you feel could be? All right. Well, let's check it out. Here we go. The very first thing you do, right, is what I said, box in your variable term. Always with that sign to the left. You're going to do additive inverse first, so I'm going to add 9 to both sides. Those cancel. I end up with negative k over 4. And you could have the negative there or out front. Doesn't matter. Okay, 15 plus 10 would be 25, but 15 plus 9 is 24. So then what I do is I box in just my variable. Now, if this k is here, if I just multiply by positive 4, right, because it's k divided by 4, so I'm going to multiply. If I just multiply by a positive 4, that negative remains on the k. We cannot have that. We got to get rid of everything except for the k. So that's why you're going to multiply by a negative 4 here. So when you multiply by a negative 4 on both sides, these cancel out. You end up with k here. Over here you end up with a negative 96. And we just multiplied both sides by a negative number. I'm going to go ahead and flip the sign. So if you want to express it, like we talked about when we were correcting homework, right? If you want to express it with the k on the left side and then negative 96 on the right, you need to make sure the alligator mouth is eating the 96, or the negative 96, sorry. Okay, questions about that? So everyone that ended up with it wrong, you know exactly what happened.
Does it matter if you put the variable first or if you put the
I will take either one of those. I believe all your answer keys, though, will be expressed like this. So when you guys correct it, when we get together tomorrow, okay, if you have that, it'll probably look like, it will look like that on our answer key. Okay. Okay, guys, other questions? Okay, let's go to a different type of problem. Here we go. 370. Let's take a look. It ends up being on 371. Number 52. All right, number 52 says, write an inequality to represent each situation, then solve each inequality. Now what we have is we have a little bit of our writing expressions, writing equations lesson involved with this. So if you look at 52, it says 12 less than a number is at most 20. Okay? So, step one. This was a little bit from yesterday. Okay? Step one is we have our variable on one side, and it would be compared to the number on the other. That number, of course, is 20, right? So here's what it does say. 12 less than. Remember we talked about less than? Means that instead of putting 12 minus, it is whatever minus 12. So don't forget that little trick word then. That would be the proper way to write this expression on this side. 12 less than a number. Your book has it as n. I don't care if you write an n or an x. Okay, it doesn't tell us which variable to use, so I'm pretty flexible on that. Now, just like yesterday, all right, after we have our two expressions, you're going to go ahead. Now, of course, the second expression is a little more challenging than yesterday, right? But step 2 is still exactly the same type of thing. Remember, the word is means equal. But this has a little bit more to it, right? Is at most 20. So you ask yourself, if this over here was at most 20, could it be equal to 20?
Yes.
Yeah. Can it be more than 20? No, it has to be less. Less than or equal to 20. Now, of course, it does say solve the inequality. So that's our inequality. And now comes step 3, and we're going to go ahead and solve it. So this one's a little easier. And I'm going to go ahead and add 12. And then I'm going to go ahead and add 12 to the second side, the other side. All right? Don't have to flip the sign because all I'm doing is adding. It's not multiplying or dividing or by a negative number, obviously. So 20 plus 12 is 32. I just bring my inequality sign down. And we have n is less than or equal to 32. So I believe on your key, guys, you're gonna have to have both that and that. Okay, to get it right. All right, questions on that one? Okay, go ahead then and start problem number 50. Number 50, try that out. Go. Okay, anyone still need more time on that one? All right, give you about 15 more seconds there, guys. That whole section, if you feel good about it, you can go ahead and continue on that section if you'd like. Okay, here we go. Go ahead and turn to your neighbor and share both your inequality sentence along with your solution, all right? Go.
I got x is equal to or less than negative 2. Oh, wait.
Did you say that negative means the variable first or not? Do you have to put the variable first or does it?
It doesn't matter, it just has to be sound.
All right, there's some discussion going on. Let's take a look at this. Number 50, 18 as at least the product of negative 6 and a number. So you have 18. You see where it says is at least? That's where, well, the inequality sign is going to go. Okay, it'd normally be an equal sign, right? But it's an inequality sign. After that, it says the product of, that means it's multiplication of these two things, -6 and a number. So they have -6 and n for number. If you put an x, that's okay. So let's go back to our inequality. Is at least. So 18 is at least. Can it be equal to that? You say is at least that? Yeah, it could be equal. If I say you are at least 54 inches tall, could you be 54 inches tall? Yeah. What else could you be, though? Could you be taller or shorter? If you say is at least, yeah, you could be taller than that, right? So 18 is equal to, but it could be larger because it's at least. It's not smaller. It's at least this. Okay, so here we go. At this point, right, boxing your variable, it's being multiplied with -6. I'm going to divide by -6. Whatever I do to one side, I do to the other. So I end up with n here, -3 here, but I just divided multiplicative inverse by a negative number. I go ahead and flip my sign. So there's one, or of course, if you flip-flop n and -3, make sure the alligator mouth has eaten the n. N is greater than or equal to -3. Is at least, I heard a couple people be like, wait, what? What? Huh? Okay, well, if I say, remember the sign yesterday, if I say, the cutout or the figure, you have to be at least for this tall to ride the ride, right? That meant that you had to be either the same height or larger, right? Of course, taller would be going with that story, the word taller, but it basically bigger, larger than, okay?
Aren't you supposed to change the sign because if you're dividing by negative?
Yeah, I did. And then I just rewrote it, but because I flip-flopped these right here. Remember, the n is being eaten in both of these. Okay, makes sense. Okay. Okay, guys. Other questions? Okay, here we go. Another one. All right, we have a couple different more type of problems to go. Here we go. Number 10. Let's take a look at number 10 on page 370. All right, let's go ahead and close read this. It says, Isabel earns $50, $2.50 for each table she cleans. Write an inequality to find out how many she must clean to earn at least. All right, so listen, guys. I'm going to go ahead. I'm going to use a bar diagram for this. It still works when we're dealing with this. So here's our bar diagram. Okay. Remember, setting up your bar diagram, the total that everything is being compared to goes up to the top. Well, in this case, the total that's trying to be earned, right, is $120. That's the total amount. Now, the storyline, whatever the situation is, okay, is going to create our expression down below. And remember, whatever the expression is going to be the same length or equal to the top. All right, let me say that again. It's not going to be equal because it's talking about an inequality, so just know that. But that's just how we can still use it to set it up. So here we go. It says Isabel earns $50 plus, well, guys, $50 is a flat amount of money. This, we could just say here to here is $50. But after that, she's going to earn $2.50 for each table she cleans. So, 250, 250, 250, okay, I'm not going to keep going. I'll just put dot, dot, dot. What it is, right, is it's repetitiveness over and over and over again. So I can add all these 250s or I can multiply, and that's, of course, what we're going to do is we're going to multiply. The issue is that we don't know how many 250s are because we don't know how many tables she has to clean, right? That is what they're asking. That is our unknown. That is our x. So if I'm going to go ahead and write this, I'm going to go ahead and write 250. You could put 2.50 or you could just put 2.5. It's up to you. It means the same thing. 250 times x. We don't know how many tables. What we do know is if you go, well, what does that mean? It's, well, if she cleaned 2 tables, she'd make $5. 250 times 2. If she cleaned 4 tables, it'd be 250 times 4, right? So that's how many tables? 250 times however many tables. Plus that extra $50 she starts off with. This whole expression down here is being compared to $120. Now, we just did step 4, write your expression. However, part of that, I guess you could almost say that's step 4a, and this we're about to do step 4b, I guess you could even say, is you have to slow down, make sure it is not an equal sign. We have to reread it to see what it's saying. It says she must clean to earn at least $120. Now remember, this is how much she earns. This is being compared to 120. This is how much she earns. So guys, will she be happy if she makes exactly 120? Yeah. Will she be happy if she makes less than 120? No, she needs to make at least 120. Does it say what she's going to buy? No. We don't know. She's going to go buy some clothing, I guess. I don't know. All right? But she wants at least 120. Does she have to have more than 120 possibly? Yeah. She'll be happy with the same amount of 120 or more than 120. Now it does say solve, right? So step 6. I'm going to go ahead and solve. So here's our variable expression. I'm going to go ahead and subtract 50 from both sides. So I get these cancel. I end up with 2.5x is greater than or equal to 70. And there's our variable. It's being multiplied with 2.5, so I'm going to divide by 2.5. It's a positive, so those cancel. I do not flip my inequality. And this is one of those where a calculator will sure help. So 70 divided by 2.5 equals 28. So, and then of course, don't forget, we can call it step 7, right? But it's a step that's on all word problems. We need to make sure that we write our units. Now, I will accept it like this, but the proper answer is at least 28 tables. I'll even take something like 28 tables or more, right? That's what we're looking for. Okay, this right here in real word form looks like that. She has to clean at least, not exactly 28 tables. If you just put 28 tables, it's going to be wrong. You have to include that inequality, okay? Either in written form or symbol form. All right, questions on that one? Okay, the last type of problem, we're going to skip ahead to number 58. The last type of problem, number 58, has a little twist. You don't have very many of these to do, but I want to make sure I do one with you because they're a little different. Okay? It says graph each compound inequality on a number line. So there are certain situations. If you take a look at number 58, it says 8 is less than or equal to G, but G has to be smaller than 14. So here's what you're going to do. Step 1, you're going to make a graph with both of those numbers in it. So in this case, it's 8 and 14. Now, step 2 is concentrate on the first part when the g is being compared to 8. Now remember, this has part of an equal sign. We're going to put a dot. G is being eaten by the alligator mouth, which means it is larger than 8. So listen, I'm going to go ahead and I'm going to do this. Don't put an arrow on it yet, though. Okay? Bless you. If I put an arrow on that, that implies that it goes on an infinite amount. It keeps going to all the larger numbers. But that's not going to be true on this one. That is because of step 3. Now we focus in on this one. So we go to 14. There is no equal sign, so it's a circle. But g is smaller than 14. So guess what? I go ahead and do the same. Now, you could say we'll call this step star instead of 4 step. On this one, here's all you need to do. That shows it can be 8 and all of the numbers on a number line all the way up until 14. Okay? Your book will show it like we talked about with the arrows. Your book might show it like the number line being shaded like that rather than the up above. Okay? I'm okay with either one. It's a little easier to do that though. Okay? Questions on that one? All right, guys. Compound inequalities.